Alright guys, your essential question for today is a continuation from section 1.3 on evaluating limits analytically. So we're going to be looking specifically whenever you run into an uh-oh scenario. Now when we talked about evaluating limits analytically previously, we said that as long as you end up getting a real number, direct substitution is the most easy and useful method for evaluating these limits. However, if you run into a scenario, for example, like this, where I want you to find the limit as x approaches 2 for this rational function, when you plug in or do direct substitution of 2, you end up getting 0 over 0, which this is called indeterminate form, because the limit cannot be determined this way. So we run into a problem. If direct substitution results in 0 over 0 or other indeterminates, such as infinity over infinity or infinity times 0 or infinity minus infinity, the limit probably exists, but we just have to find a new method of evaluating it. So what we typically do is we try to rewrite that function in terms of another function. Or in other words, we're going to use some algebra or trigonometric tricks to help us rewrite the function. So in other words, we're going to try and rewrite this function, the x squared minus 4x plus 4 over x squared minus x minus 2, as an equivalent function, and then hopefully doing that we'll be able to do direct substitution. So the question is, how can we simplify x squared minus 4x plus 4 over x squared minus x minus 2 to solve this? So obviously this means we've got to remember some of our algebra that we learned in previous courses. Alright, so here are some strategies to help us find limits. To find limits analytically, try your true and trusted method first. Try direct substitution. If direct substitution fails, then you're going to have to rewrite and find a function that is equivalent to the original function, except at that one point. Then use direct substitution methods. Methods to help us rewrite it include, but aren't limited to, factoring or dividing out technique, rationalizing the numerator and denominator, eliminating embedded denominators, trigonometric identities, or any type of algebraic legal creativity that you can think of. Those are all valid methods that you can use. Alright, so let's take a look at this example that's similar to the one we just saw. If I try to do direct substitution, I would end up getting 0 over 0. So we can't just do direct substitution first here. We're going to have to rewrite this with an equivalent expression. So first thing I notice up top is that this is a difference of two squares, x squared minus 4. So I'm going to rewrite that as x plus 2 and x minus 2. And I'm going to go ahead and write the limit as x approaches 2. And then I also notice that in the denominator, this is a trinomial. In fact, it's a nice trinomial that has a lead coefficient of 1. The last term is negative 2, so I want factors of negative 2. That would give me negative 1. That would be a negative 2 and a positive 1. So that means that would factor into x minus 2 and x plus 1. So basically what I've done is I've rewritten this expression as an equivalent expression of this. And here's the trick. Because I've done that, I notice that this x minus 2 here in the numerator and this x minus 2 here in the denominator, they will cancel each other out and reduce. And so then that'll leave me just with x plus 2 over x plus 1. Now I can use my direct substitution to figure out what my limit is. If I plug in 2 now, I'm going to have 2 plus 2 over 2 plus 1, and that would give me 4/3. So the limit as x approaches 2 for that function, I'm just going to put f of x, is equal to 4/3. So we can use direct substitution, but only after we've done a little bit of algebra techniques to get it there. Alright, let's take a look at another example. Notice that this one's a little bit different. It involves a square root. Now, I'm not saying that this method will always work, but typically whenever you see a square root, the best thing to help you do this is the conjugate. But first, before I jump the fence, notice that if I do plug in 2 into the numerator and the denominator, it gives me indeterminate form. So that's why I can't just do direct substitution as is. So I do notice that this has got a radical, so I'm going to use the conjugate of the square root of y plus 2 minus 2, and the conjugate of that would be the square root of y plus 2 plus 2. Remember, with the conjugate, you just change the sign in the middle. And so I'm going to multiply top and bottom by this conjugate, because notice if I multiply by the same number, that's really like I'm multiplying by 1. So there we go. And now I'm going to do some algebra that I learned in 10th grade. In the numerator, if I FOIL this out, the square root of y plus 2 times the square root of y plus 2 will just be y plus 2. And then notice what happens when you multiply by the conjugate. The outer cancels out with the inner, and so then that plus 2 square root of y plus 2 and then the minus 2 square root of y plus 2, they cancel out. So now I can do last, negative 2 times positive 2, so that would be negative 4. And then I'm not going to multiply the non-conjugate pairs, and you're probably wondering, well, why are you going to do that? I'm going to show you why. It's actually the little algebra trick that is important. Let me go ahead and write everything else down. I am going to simplify the numerator, so I'm going to have the limit as x approaches 2, and then y plus 2 minus 4, 2 minus 4, that's going to be negative 2. And you can probably see now why I didn't want to FOIL out the non-conjugate pair. The reason is because if you notice, the numerator now will cancel out with this term in the denominator, so that will cancel out. And so then that will leave me an understood 1 in the numerator. So the limit as x approaches 2 of 1 over the square root of y plus 2 plus 2. And now I can do direct substitution. I can plug in that 2, and I'm going to get 1 over the square root of 2 plus 2 plus 2. And so that's going to be 1 over the square root of 4 plus 2. So that's going to be 1 over 2 plus 2. So that would be 1/4. So the limit as x approaches 2 for this function is 1/4. And that would be the answer to that problem. All right, let's take a look at another example. All right, for this one, notice that it wants me to evaluate the limit analytically. The limit as h approaches 0. Notice that h is in the numerator and the denominator. And notice again that if I actually plugged in 0, I would get indeterminate form. So that means I've got to do some algebra to it. First thing I notice is a GCF, a greatest common factor of h in the numerator. So what I'm going to do is I'm going to factor out that GCF of h. So I'm going to have the limit as h approaches 0. I'm going to factor out, let me highlight it for you so you can see it. I'm going to factor out one of those h's. So that's going to be h on the outside, and that's going to leave me 3h plus 2 on the inside, and h on the denominator. The h's are going to cross out, and so that's going to leave me the limit as h approaches 0 of 3h plus 2. And now I can do direct substitution. Use your direct substitution, and so that's going to give me 3 times 0 plus 2, so that'll give me 2. So the limit for this function, f of h, is 2 for this problem. So that one's not too bad. So remember, look for dots, look for trinomials, look for GCFs, look for radicals and conjugates. All right, let's take a look at one more. I think I have one more. Nope, two more, sorry. All right, let's take a look at this one. For this one, it wants me to find the limit as h approaches 2 of h cubed minus 8 over h minus 2. All right, now this one might not be as easy to see, but this is actually what we call a difference of two cubes. Not a difference of two squares, but a difference of two cubes. The reason is because h is cubed here, and the number 8, if you remember, 2 to the third power is 8. So in other words, the cube root of 8 is 2, just like the cube root of h cubed is 8. So this is a difference of two cubes. And we can actually factor the difference of two cubes very easily. There's a little set of patterns to factor it. What you do is you set up a small binomial. It's always a binomial. And then you set up a larger trinomial. So this is how it factors out. And what you do is you take the cube root of h, the first term, the cube root of h cubed is h. The cube root of 8 is 2. And then what you do is you square this first term, so that would be 8 squared. You square this term, so 2 squared is 4. And then you multiply these two terms together, and so that would be 2h. And then you do something called, I like to call sop your signs. Just like a biscuit, you sop it with gravy, S-O-P. S stands for the same sign, so this is going to be negative. O stands for opposite, so it's going to be opposite of a negative, so that's a positive. And then P always stands for positive, so this last sign is always going to be a positive. So that's how you factor a difference of two cubes. You can also factor out a sum of two cubes, but you would still do it the same way. Alright, so we factored that, and so the numerator has been factored, and then you notice that the reason why I did that is this h minus 2 in the numerator will cancel out with this h minus 2 in the denominator, so that cancels out, and that leaves me the limit as h approaches 2 of h squared plus 2h plus 4, and so now I can use direct substitution. And so if I plug in 2, I'm going to have 2 squared plus 2 times 2 plus 4, and that should give me 12. So the limit as h approaches 2 for this function is 12. Alright, let's look at one more. Alright, now sometimes you won't even have to factor or do difference to squares or sum of difference to cubes. Sometimes you've just got to do the algebra and FOIL stuff out. For example, for this one, if I were to plug in 0, I notice that I would get the indeterminate form. So I'm going to have to, try and work this out a little bit. So notice there's nothing I can factor, but I do notice that this is squared. So what I'm going to do is I'm just going to go ahead and FOIL that out. Remember that h minus 5 squared is the same thing as h minus 5 times h minus 5. So if I FOIL that out, I'm going to get h squared minus 25h, nope, sorry, not 25, let me see if I can do my arithmetic again, minus 10h plus 25 minus 25. So I FOILed that out, and then I brought down the minus 25, and this is over h. And then you're probably thinking, well, that didn't help anything. Well, notice what I have here. I've got a positive 25 and a negative 25, so they cancel each other out. So that'll leave me h squared minus 10h over h. And then I notice, lo and behold, there is a GCF in the numerator, so I can factor out, let me highlight it for you, I can factor out a common h, and so then that'll leave me h minus 10 over h, and then you probably see now why I wanted to do that, because the h's will cross out, and now I can use direct substitution, and that'll be 0 minus 10, so that'll be negative 10. And so the limit as h approaches 0 for this function is negative 10. Alright, so as you can tell, there's a lot of algebra that you have to review to do problems like this. Remember, as long as you do legal, creative things to solve these problems, you shouldn't have any issue with them. Alright, good luck, and see you again.